Hi, good day. Today we're going to solve some problems from University Physics Chapter 11. Let's get started. 11.15. To strengthen his arm and chest muscles, an 82-kilogram athlete who is 2 meters tall is doing push-ups as shown in the figure. His center of mass is 1.15 meters from the bottom of his feet, and the center of his palms are 30 centimeters from the top of his head. Find the force the floor exerts on each hand, assuming that both feet exert the same force and both palms do likewise. So here's the figure, and here is the free body diagram. And the equivalent distances. So I just indicated here the normal forces. If we let point W be the pivot point, we can get this equation because, as we know, the summation of torques is equal to 0. So we can transpose that to become 0.55 times the normal of the hands equals 1.15 times the normal of the feet. And we can't find anything, so we let F be the pivot point instead. And we get this equation, and we just transpose and substitute the values to get the normal of the hands. One hand's 270 newtons, and to get the feet, just substitute the first equation and you get 130 newtons. 11.39. In a material testing laboratory, a metal wire made of a new alloy is found to break when tensile force of 90.8 newtons is applied perpendicular to each hand. If the diameter of the wire is 1.84 millimeters, what is the breaking stress of the alloy? So we know stress equals force over area, so we can get the breaking stress by using the breaking force, and we get 3.41 times 10 to the 7 pascals as the breaking stress. And lastly, 11.63, as part of an exercise program, a 75-kilogram person does toe raises in which he raises his entire body weight on the ball of one foot. The Achilles tendon pulls straight upward on the heel bone of the foot. This tendon is 25 centimeters long, as a cross-sectional area of 78 square millimeters, and a Young's modulus of 1417 megapascals. Make a free body diagram and find what the force the Achilles tendon exerts on the heel, and how many millimeters does the exercise stretch his Achilles tendon. So here's the figure, and here's the free body diagram. So we know weight is at the ball of his foot according to the figure, which is 4.6 centimeters from the heel. That's how we got the free body diagram. So first we let point W be the pivot point, or the weight be the pivot point. And since they're moving in the same opposite direction, we can get 4.6T equals 12.5 newtons, substitute, and we can get these values. So to get Young's modulus, we know it's equal to that, and we can get change of length by transposing, and we get change of length equals 4.36 times 10 to the negative 3 meters, or 4.4 millimeters. Thank you for watching. I hope you learned something.